There we go. All right, like I was saying, when you balance an equation, you are basically trying to meet the law of conservation of matter, because it states that no matter can be created or destroyed, right? So let me show you kind of how that works with a different perspective here. So basically, this equation right here, oops, come on you. Sorry, it won't let me type. There we go. This right here, H2 plus O2 yields H2O, right? So that's water. Okay, so if we actually take the mass that's there, so to know what, this is not balanced, obviously, so hydrogen in the periodic table is 1.01 if you look at it, so this would be 2.02 right here. Oops, 2.02, sorry. And that's grams per mole, but we're just gonna leave it at that. And then oxygen, each oxygen atom is 16, and there are 2 here, so this is 32. Oops, why is it doing that? I hate this stuff when it does that. Thing is, I need to start by just putting my finger directly there. Okay, so this becomes 34.02, right? If you add it. Okay, now look at the other side. We have 2 H2Os. We have 2.02 here, right? 2 H2s, 2.02 plus 16, and this is 18.02. So this is not equal, and it's supposed to be. You see that? So by balancing, let's do that now and see if we can do that. All right, so let's erase that right there, all of this. Let's just erase. Oops, what happened? I said let's erase, and everything went away. Okay, there we go. All right, so let's erase. I'll just erase everything. I was gonna erase it differently, but okay, so we are going again, and now we're doing the same thing, except this time we're gonna balance it first before we do the multiplication. So H2 plus O2 yields H2O. Okay, so you notice that on the right, we only have 1 oxygen, which means we need 2, so we put a 2 in front of that. By the way, you cannot add subscripts or change in any way what's there. So all you can do is add what is known as coefficients, right? So that's what we're doing here. And this one has a 2 in front of it. Okay, now if we add these, you can see that this is going to be 2 times 2, so that's 4, right? 4 hydrogens, so that is, whoops, I don't like this thing when it does that. That is 4.04 here.
You have to add the 2 to both sides?
Yeah, I'm just trying to show you why we balanced. Now
Okay.
this should be a true statement right here. So this is 2 times 2 is 4. So again, 4.04 plus 32. See? This time it does hold true. So this becomes 36.04, right? And this is equal to 36.04, you see? Whereas before it wasn't. And so that's a mathematical proof right there that it does work to balance. Okay, so now let's see how we, all the rules and stuff. So I'm gonna stop this share just so that I just wanted you to see that first. All right, and now I'm going to share my screen. Hopefully it's still there. There we go. Yeah, and we're gonna look at this PowerPoint called balancing equations. Mm-hmm. Can you see it okay?
Yes. Yes,
Okay.
I can.
All right, so we are going to look at how to balance. Yeah, okay, how to balance equations. All right, so when you're looking at this is symbolism, okay? in chemistry. So if you look at this particular Cl2 that is on there, the first one, that is telling you that two atoms of chlorine are bonded together. See, that means you cannot change this, right? Because this is a molecule. Next, you have two atoms of chlorine, period. They're separate though. And then this one is telling you that you have two of the first. You see that? So let's look at kind of what that looks like officially in see? So that makes more sense, right? When you look at it like that. And when you have something that's bonded together, you cannot change it. You cannot add, change that 2 for a 3 or change whatever, or change it to a 1. No, you have to add a 2 in front of it. Okay. If you want to multiply it or change it in any way. And usually, and I know that a lot of people will balance by putting a half somewhere, but a half is not a correct balance. So don't balance using half numbers. If you need to use half numbers, that means you're going to have to double anyway. So don't. And the other thing, if you end up with 2, 2, 4, you can always simplify to 1, 1, 2, right? So just remember that. It is part of the rules of this. So some of them have parentheses like this one, right? And when they have parentheses, whatever's inside, remember, that's what I told you, it's being multiplied by the subscript. So that means there are 2 oxygens and 2 hydrogens, right? So like that. See that? That's what that looks like when you look at it. All right. So let's see if you guys got this. Number 1. How many atoms are in this one?
3.
3. That means 1 atom of each, right? That's correct.
Yes.
How many atoms are in this one?
5.
5. Okay, that is correct. And that means you have one calcium and 2 oxygens and 2 hydrogens, but together, right? 2 OHs. And then this one?
7.
Nope.
1, 2, 3, 4, 5, 6, 7.
If you had 5 before, right?
Oh, so to be 8.
You're multiplying it times 3, so that would be 15 total.
Oh my heavens. Oh, so the coefficient 3 is
Multiplies everything in front of it.
everything.
Yes.
Everything.
Everything.
Okay.
Yes,
Okay,
in
let
front
me
of
write
it.
that.
That, when you separate it by a plus, that means it's something else, right? So that's how you know. See, here you have 1 oxygen, 1 nitrogen, 1 sodium, and 1 hydrogen. 2 of each, like I said, and here you have 3 calciums. See, so that is 15. You see?
Okay.
So that's what that means. Yeah, that's why I wanted you to see the symbolism behind it. That's why this upper one, the 2Cl2, is showing you that there actually are 2 of those. All right. Okay, so let's look at the rest of it. How do we balance? Okay, so, and this is important, this little thing that we're going to have on the side right here. This is known as an activity chart. And we are going to also look at a different type of reactions here in a minute. We kind of go together. So I just wanted you to see what it was like to balance something. So we're going to do one balancing and we're going to have a couple of tips. All right, so predict the products and balance these. Okay, predicting products is harder, but you have these. So anything above can replace anything below in an equation, but nothing below can replace anything above it, okay? So basically potassium can replace anything on this whole chart. But sodium cannot replace potassium, but it can replace the rest of them. You see, that's kind of how that works. All right. So iron and copper sulfate. Okay, so you got to look at iron, and copper is below. Here, let me get my spotlight. Iron's right here. And iron's the lonely one, right? So loneliness means it will replace that one, if it will. We don't know yet, but we're checking. So iron is above copper. So yes, this reaction will take place. And iron will take the place of copper. Usually they will tell you which iron this is because we have no way of knowing otherwise. Nickel and sodium. Okay, so nickel is below sodium, so this reaction will not take place. You see that? Because sodium is way up here and nickel's below it, and nickel's the lonely one. And see, if something's already bonded, the metal that's going to replace it has to be stronger. And in this case, it is not, so it will not happen. All right, next one. Aluminum and copper. Aluminum is above copper, so yes, that will happen. Lithium and zinc. Lithium is above zinc, so yes, that will happen. And then this is just water, but lithium and hydrogen. So in this case, lithium is above hydrogen, so yes, it will happen again. All right, so, and that one's just two things getting together. So the first, all of the first ones are called single displacement reactions. The first 5 reactions. The next one's called a synthesis, and we'll look at those in a minute. But basically what happens here, oops, let me see. I always have to fix this thing and I forget about it. And then I end up having to fix it afterwards because I forgot about it. Okay. All right.
You said the first 5 were what?
Hold on. Let me fix this because this is annoying me. That it doesn't, it needs to stretch more. See, that's all it needs. And then it fits. Hold on. There we go. Okay, now I can go back to being presenter. All right. So, okay. So, like I said, the top, the one that's alone, you know, like it's not being reacted yet, like in this case, iron, has to be above the metal that's in the compound, which is copper, in order to replace it. So it is indeed, right? Because iron's way above, is 1, 2, 3, 4, 5, 6 above copper. So yes, it will replace it. Nickel and sodium, no, because nickel's below sodium. You see that? On the list, yeah. Aluminum and copper, yes. Lithium and zinc, yes. Lithium and hydrogen, yes. And the other one is not a replacement because there's nothing bonded to the oxygen. So you know that it's a single replacement because you have a lonely metal, right? Or a lonely element that is going to be incorporated into the compound. And then the one that was in the compound is going to get booted out like that. You see that?
Ah, okay.
That's why it's called a single replacement or single displacement. Okay, this
the chart that's right here to the right, is this something we have to have memorized, or is that how it shows up on the periodic table?
Actually, no, that is something I give you guys, and this is how I give it to you.
Okay.
So you can take a picture of it and just, you know, keep it as part of your reactivity series. Yeah, I think it's in there too, but I'm not sure. I'll have to look. And then aluminum and copper, we said it would happen. So aluminum is a 3. And remember, you still have to do your ratios like you know them, right? So aluminum is a 3 and chlorine's a 1. So there you go. And then lithium and zinc. Zinc is a 2, lithium's a 1. So there you go. Lithium and hydrogen, they're 1 to 1. So this would be the same. Except when this happens, it is still a single displacement, but it will yield a metal hydroxide and hydrogen. You see how it pulled it out? Hydrogen pulled out, but the oxygen is so reactive that it retained the hydrogen. And that's how it works. And then aluminum and oxygen, that's just what is known as a synthesis or combination reaction, because you have two things becoming one. You see that? So you don't have anything else. It's just one thing. So you had two elements on the left-hand side, which is known as the reactants, by the way, and then the products became one. Now, to balance, the best tip that I can give you is always look at the most complicated one first. So this is what I would do. I'm just going to annotate now what I would do myself. All right, I'm going to look at this guy, okay, and I'm going to compare. So you notice that SO4 we have 3 of, here we only have 2, so I would put a 3 in front of here. That gives me 3 coppers. And then the rest is just an iron that you have 2 of, so I would put the 2 there. And yeah, this is a fast balancing because I'm used to it, right? But this one obviously didn't happen, so no need to balance. Again, the most complicated one is the one with the most elements, or most atoms, in this case, most atoms. So we're looking at this one. And you notice that chlorine here is 3, chlorine here is 2. So the only way to make one like the other is to double this one. Why? Because that becomes an even number. And now we can put a 3 in front of that one because that becomes 6 again, right? And then 3 goes here, and the 2 for the aluminum goes there. And there you go. That's the balance. Again, looking at this one, most complicated one, or it could be this one, but this one actually has 2 more, right? Than this one right here, right? So we do not want to do this one first. We want to look at the one I underlined and compare. All right, so let's look. Okay, we have same amount of carbonate, right? So we don't need to increase the carbonate. We're good with that. So the only thing to balance is actually the lithium. You see that? Everything else was already balanced. You see? That one was an easy one. All right, this one's not going to be easy because it's split. When you have a split hydrogen or a split oxygen, it makes life a little more complicated. So the one that has the most atoms is this one, or different kinds of atoms is that one. So we'll look at it first. And what we can see is that the oxygen is balanced, right? But the hydrogen isn't, because hydrogen, even if we add these, 1 plus 2 is 3, and on this side we have an even number. So that means we need to make this side even by putting a 2 in front of that. That gives me 2 hydrogens, 2 oxygens. Now that we have 2 oxygens, we know that we need to put a 2 in front of this one, right? Because that gives us 4 hydrogens, which is 2 times 1 is 2 plus 2 is 4. So we got that balanced. And the oxygen is 2 times 1 is 2, and 2 times 1 is 2 on this side. So it's balanced. The only thing that's not balanced is the lithium, right? So we need a 2 right there. And there we go. It's all balanced. And then this bottom one, I see, okay, Al2, that should be O3. I don't know why on earth that 3 is not there, but it should be Al2O3 because, you know, aluminum is a 3, oxygen is a 1. All right, so let's look at balancing this one, right? It's obvious. We have to put 2 in front of it because otherwise the oxygen we won't be able to balance. So now we know that there's a 3 here and there's a 4 here. And that's how you balance a reaction all the way. So see how I always picked the most complicated one that I was going to compare everything against? That's the key. And then to leave the elements that are by themselves, that modify nothing else, after for the last balance. You notice I didn't balance the aluminum until last. Why? Because aluminum, it's all alone. oxygen at least had 2 of them, right? So we needed to balance it first. Because if it had been alone, we could have just put any number in front of it. There would have been no need to make it even. So that's why we do that. Okay, so now let's look at the actual answers and see if we got them right. Come on, let's go. There we go. All right, there we go. There we go. See, we did get them right. So that, by the way, this is because I didn't stretch it also. I forgot. See, I told you there's sometimes I don't stretch something. It goes away, but the 3 is under there somewhere. If I just escape and do it again, you'll see that the 3 is there. See it down there? It just needs to be stretched so the 3 fits. There it is. Good thing I know my chemistry, otherwise we would have never balanced that one. You can't balance something that won't happen, okay? That's the way it works, period. I mean, there's just no way. So if something is off, you'll never be able to balance it. But there it is right there. See, there's the 3 that I put in. Okay, and there's all your balanced. Okay, so everything here is balanced. Now, let's look at another thing. I mean, there are tons of practice here, so you can go back and try to balance yourself later. But first, what we're going to do is we're going to not balance. Yeah, I always say save, but it doesn't matter because it goes away anyway. Because it doesn't save it to that. Okay, so I'm going to teach you a different method. For those of you who are learning, this is usually a good thing. And the only thing is you have to be extremely meticulous. And by meticulous, I mean, whatever you do to the equation, you're going to have to come back and do to the other stuff. Okay, so the very first thing we're trying to determine is if this equation is balanced. As is, okay? So what we're going to do is, and I'm going to make it bigger so you can see it better.
Thank you.
So what we're going to do is we're going to actually look at it and take what is called the inventory. I call this is inventory method. Okay, so what we're going to do is count how many potassiums are on each side as it is. So let's see, I'm going to type in my numbers. Hopefully I can. Okay, so 2 potassiums on this side, right? That 2 times, right? And then 2 times potassium, that right there, that tells me there's 2 on this side. All right, here's 2 times 2 is 4 hydrogens on this side. And here we have 2 times 1 is 2 plus 2 is 4. So we can say 2 plus 2 on this one since they're split. I always suggest, that you do that when they're split because of the way they balance. And then here you have 2 oxygens on the left and 2 oxygens on the right. So this is officially balanced, as you can see. Now let's do the same method and balance the one below. See if it's balanced or see if we can balance it. Let's see here. Let's do sodium. I'm going to put it in the middle here. I usually try to do in order. So hydrogen, not like that. Hydrogen. Oh, I see. We're on capitals. That's why it wouldn't let me do it. And then tab again. Then we have chlorine, right? Like I said, I try to do it based on the order that's in there. Then we have sodium. And then the last thing we have in here is the oxygen, right? And that's it. All right, so we have the number, the right amounts, everything's there. All the elements that comprise this equation. Okay, so let's look. On this side, we have a 1 on that one and plus 1 on this one, right? Yes. On this side, we have 2, which is correct. That is balanced. On this side, we have 1 chlorine. On this side, we also have 1 chlorine. On this side, we have 1 sodium. Yep. On this side, we also have 1 sodium. Come on. Down. And on this side, we have 1 oxygen. And on this side, we also have 1 oxygen. So this equation happens to be balanced naturally. You see that? Everybody is perfectly in sync. So you didn't have to balance this one. But that doesn't mean they're all going to have to not be like that. They're not. They're not at all. All right. So let's go balance the next one. All right. This one, again, let's take inventory of what's here. And I'll say this is potassium. That's the first thing we see, right? And then the next one's nitrogen. And then the next one's oxygen. And that's all we got. All right. So I'm going to move it over a little bit. I don't like it where it is. I like it under the arrow, so that way it's a neutral zone, you know. All right. So potassium on this side, we have 1, right? Potassium on this side, we have also 1. Nitrogen on this side, we have 1. Nitrogens on this side, we have also 1. Oops, come here, you. Also, damn it, 1. And oxygens here, we have 3, right? And on this side, we have 2 plus 2. So no, it's not balanced. So remember what I said? You always inspect the most complicated one first, which is this guy, right? And compare it to the rest. Okay, you notice everybody's balanced except for the oxygen. The oxygen here is an odd number, which you'll never balance against both of these that are even unless you make it an even. So to put a 2 in front of that, see, this is where the meticulous part needs to happen. That changes that to a 2, that changes that to a 2, and that to a 6. You see that?
Yes.
Yeah, and that's where it gets difficult. So now you put a 2 in front of that one, right? Because you can see that you need two potassiums, so you put a 2 there. The nitrogen became a 2. That oxygen became a 4, right? And now look, do you see? Magic, balanced, right? All right, let's do, ooh, this one's already balanced, but I'm gonna not let you, well, we're gonna end up with these numbers, but I'm gonna show you how to balance this one, because this is a special type of reaction. It is called a combustion reaction, which you also have below here. And I'm also going to take this off because I don't want it to be balanced yet. All of these are balanced. That's what I hate about that. All right, so look. All right, so again, we only have 3 elements in this one: carbon, hydrogen, and oxygen. Isn't that amazing? Doesn't look like it, does it? It looks more complicated than that. Carbon, then we have hydrogen. I know, I like it under the thing, I'm picky. And then oxygen. Okay, that's all we have. All right, so let's do our inventory. Okay, for this one, we have 2 on this side, and we have 1 on this side, right? And you need to be looking at it and thinking the same thing I'm saying, because it'll help you start paying attention to the numbers. All right, for this one, we have 2 hydrogens, right?
Yes.
And on this one, we also have 2. On this one, we have 2 oxygens. And on this one, we have a 2 plus 1 situation, right? And yes, remember, I say separate them, because whatever you do to this one, to the CO2, is not going to happen to the water. So that's why we separate them. All right. The trick that I will show you on any combustion reaction, if you take the hydrogen, and I'll show you why in a minute, and you look at it and you say, okay, this hydrogen, When I divide it by 2, is it an even number? The answer is no, right?
Right.
Then you put a 2 in front of it. Why is that? Because this hydrogen is going to multiply this. And if you put an odd number here, look, you end up with an odd number with that oxygen. You see? That's why you check that first. That's what I learned over the years. Nobody knows this trick but me. All right, so because I came up with it. So once you do that, now you can see you have 2 times 2 is 4 carbons, right? Then you have 2 times 2 is 4 hydrogens. So you already have 2, therefore you need a 2. And that did that. Now, you see how the oxygen is all by itself? Now, you notice that I didn't change anything, and that screws up all of this. So let's go back and do the right thing like we're supposed to. See, once we put a 2 there, that becomes a 4, right? That becomes a 4, and the oxygen's alone. Okay, so then we put a 2 in front of this one, and that becomes a 4. I mean a 4, sorry. A 4. That becomes a 4. See, you have to do this. If you don't, you screw it up. That the hydrogen is untouched, but this oxygen right here becomes an 8, right? Yes? Do you agree?
2
4 times 2.
is okay. I see 8.
Yeah.
Yeah, because 4 times 2.
That's right. Okay. So now we said that we were going to check the hydrogens. And here you have 2 times 2 is 4 on the, you know what, I need to, okay. 2 times 2 is 4. And here we only have 2. So then we need to put a 2 in front of it, right? In order to satisfy that. So we put a 2 right here. And that changes this to 4. Yes. And this changes to what? 2. All right. Now, A plus 2 is 10, right?
Yes.
Okay, so when we have 10 on this side, and we only have 2 on that side, what do we need to multiply this 2 by?
5.
Exactly. Correct. And then that makes this 10. And oops, not 210. 10. 10. 10. Thank you. There. That's what I wanted to do. Okay, see? See how it balanced?
Yes, that took a little extra effort.
Oh yeah, combustion reactions, and that's what this is, by the way, are always confusing as far as that goes. Now, let's do this next one. It's another combustion reaction. So remember that the tip I showed you. Look at this number. Check it out. Is that when it divides by 2, is it an even number? The answer is yes. All right. So then we're done. We're done. We don't need to double it. So let's just do our inventory again, which I don't like this inventory method. To me, it's boring, but I'm going to do this whole thing with inventory. I don't like it. To me, it's tedious and annoying, but you know, everybody to their own. So that's my opinion. Doesn't have to be yours. And then we have a hydrogen. That's what I saw next. And then we have an oxygen, right? Okay. Oops. A little more. Okay. Now, on this side, we have 4 carbons. Yeah. And on this side, we have 1. That's how we start. On this side, we have 8. And on this side, we have hydrogens. We only have 2, right? Tap, 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 tap. Okay, 2. On this side, we have
2.
And on this side, we have
2 plus 1.
That's right.
1.
2 plus 1, because we have them separated, right? And this is why we do that. It's because it actually helps you. Come on, you. I know I'm such a perfectionist. Don't worry about me. All right. So once you look at that, you're like, okay, look at that. Immediately, carbon, 2. you need a 4 in front of it, right? Right
Yes.
there. 4 there means this is a 4. And this becomes an 8, right? Because you're multiplying those things by 4. You see that? Only those, nothing else. Here we have 8 hydrogens. We already have 2, so we need a 4 in front of here, right?
4. Yeah.
Yep, 4 here, and that becomes a
8.
4,
Wait,
right?
what?
Oh, sorry, that became an 8. Sorry, I put a 4. See, this is why I don't like it. All right, and that became, okay, so 8 plus 2 is? I mean, 8 plus 4, sorry. I said 2. I'm looking at the other number already. Yeah, sorry.
12.
12 divided by 2, because that's how many we have, with 6, right? So putting a 6 here, we would put a 6 there, which gives this 12, you see?
Mm-hmm.
Fun.
Yeah, this is the balancing. This is the, like I said, this is not my favorite type of balancing. Okay, it's just not me. I'm faster than this, and I'm, and I've always been that kind of person that can look at something and figure it out quickly. So inventory
I'm
is not for
definitely
me.
not.
Inventory is not for me. Mine is the inspection, which I'll show you in a minute how to do that. This whole sheet is for inventory. All right, so how many
1.
do we have? 1. Okay, and the other side?
1.
1,
Okay. How many on this side?
2,
2.
And on this side?
1.
1.
Okay. Oops. 1. All right, so it's quite obvious
You
that
gotta
you're
add
going
a
to have
2
to
in front.
put a 2 in front of this one, right?
Yes.
Here, and that becomes 2. Oops. And so does this one.
Mhm.
Which means, what do we need to do to the other side?
Add
Put
a
a 2 in
2
front
in
of
the front.
oxygen.
To the mercury, right? And that
Yes.
becomes 2. And look, it's all balanced.
Yep.
Nice.
Yeah.
That one was easy.
Oh,
I mean, I
yeah,
think the more we do it,
that too. Yes, you're right on that. And it also is an easier one on top of that. So the more you do, it makes sense. And okay, so this is the one where I am going to show you. Well, this one is balanced. Yeah, this one's balanced. Never mind, I'm not going to show you on this one. But I'm going to show you what to do on this one. So if you were doing the inventory method, I can tell it's balanced already. But let's say, oops, why on earth are you so tiny? I know why, because I put it in front of that other thing. Okay, so silver here, and then we got,
oh yeah, it is balanced already. You can look at it.
you can see, right? But this is
Yeah.
the group right here, and you notice the group is still intact. So we're just calling it NO3, okay? And this is where the trick comes in. There's the sodium,
Yes, sir.
right? And then there's the chlorine. Oops. Okay. So if you look at it, yes, you said it's already balanced, but isn't it easier to look
1
at
and
it
1.
like this?
Mhm.
Oops. No, don't tab. 1 on this side and 1 on this
Mhm.
side, and then 1 NO3. You see, it makes
Mhm.
life easier to say 1 NO3 and 1
1.
NO3 on that side. Yeah.
Mhm.
Instead of saying 1 nitrogen, 3
1
oxygens,
Na on this side, 1 Na on the other side.
Yep. And then 1
And
chlorine
1 and 1.
and 1 there. And that's kind of how you do this. So it makes life a lot easier if you do it with the group. When you see a group, like in a group, I mean like a polyatomic ion such as NO3, right? That survives the reaction intact, like this one did right here. See? And instead of saying N, 1 N and 3 O's, you just go NO3. See, it makes your visual a lot softer and less complicated. All right, so we're going to come back to this sheet in a minute because we're going to classify. Now, I'm going to show you my way.
Okay.
This is the balancing equations practice part. This one is my way of doing things. All right, so it's going to go faster because, you know, you'll see. Okay, so what I told you was to always check which one is the most complicated one first, right? And that's what we're going to do. We're going to always check the one that looks the most complicated. And that would be the NH3, correct? So that would be
Yes.
this guy. Oh, I know what it is. I need to give it permission, and I can't because I'm blocking. There we go. Enable. Aha, there we go. That's why I couldn't do the highlighting. Okay, so there. We know it's you. You are the key to this balance. All right, so we are going to look at that one. All right, so when we look at this and we compare it against both of the others, right? Because they're both separate, so it doesn't matter which one. You can see that there needs to be a 2 in front of the nitrogen. Of the
And that's nitrogen, right?
right? And that changes this one to a 6. You see that? So 2 times 3 is 6. So that means you need a 3
You have to put
for that one.
3 in front of the H.
Yeah, see how fast that went?
Got it.
Mm-hmm.
That's the inspection
Yes.
method. You just inspect it. I like it a lot better, but that's just me because I'm, you know. All right, look at this one. All right, again, we're inspecting. What do you see that's different? The KC is the same, the oxygen. This side is even, this side is odd. We never can do it unless we put a 2 in front of that, right? And make it even.
Right.
And now we can see that we need a 2 in front of that.
2 right there.
And
a 3 in front of it.
Yeah, see how easy that is?
Yeah.
But you have to have my tips. That's the thing. Okay, now the next one, you can do either one because they're both just as complicated as the other, right? And they're pretty much the same. So let's just do the NaCl, just because we're going to focus on one of them. We got to focus on one. All right, so you can see you put a 2 in front of that. And see, that 2 tells you need 2 sodiums. So boom, and there it is, balance. You see? So you could have started with the sodium, it would have been the same difference. All right. Ooh, here we go. This is where I told you to focus on the one that has the most everythings, and that would be this guy. Right?
Mm-hmm.
All right. So comparing, you notice you have NO3s, how many?
6.
No, NO3s is the whole parentheses, remember. You have
2. I'm sorry.
Right. So you need a 2 right here.
You got to put a 2 in front.
And that means you need a 2
You
here.
got to put a 2 in front of the other side.
There you go. And look, it balances the chlorine. You see that?
Yeah.
Yeah.
Yep. I like this 10 times better.
It's easier now that we're doing it.
Yeah, it's especially, see, but the other one helps you understand this one, I think. So, okay, so that's the most complicated one, right? So let's look at what we see. All right, so we have, how many? We have 3 of them, and we have how many over here?
2.
1.
So we need a 3 in front of it, right? Right.
Mm-hmm.
And that gives us how many potassiums?
6. So we need to put a 6 in front.
Yep.
And that gave us, put a 2 in front of the AlBr3.
Yep. Perfect. You see that? It's balanced. Now here's a combustion. Remember, these are the tricky ones. This is the one where you got to look at the one. Okay. So I'm used to this combustion because you always will see a CH whatever plus oxygen becoming carbon dioxide and water. So you know this is a combustion reaction. Hence, always check this little number, the hydrogen. Is that divisible by 2? Yes. Is the answer an even or an odd?
Odd.
Which means that odd would end up here, right? That would be a 9
9.
right there. And see, we cannot have 9 because we have 2. You see that? We have 2 right here.
Oh, yeah. Mm-hmm.
Right? So then this needs to be an even number. So that means we need to multiply this one by 2 immediately. See, that's why I have my little check. The check of this one thing right here. This is all I check. I check these hydrogens right there. That's what I check first. And then I know that I need a double, because if when it divides by 2, it's an odd number, it's going to go in front of this. That's going to become an odd. And then you're going to have to multiply by 2 anyway. So might as well start with 2. All right. So now 2 times 8 is?
16.
That means we need 16 carbons, right?
Mm-hmm.
Don't worry about the oxygens. They'll balance themselves later. 2 times 18 is 36.
32, 36.
Okay, but divided by 2, right? Because this is already 2. Again, it's 18. See? Now you see where the double came from, why it's there. Now, this is the part where a lot of people go like, okay, so how do we balance? Okay, everything else is balanced. So I'm going to make a quick annotation over here with my pen so that you see how I do this part. Okay, so I do 16 times 2 is 32, right?
36.
32.
Oh, I'm sorry. You said 16 and not 18.
16 times 2, yeah, and plus 18. That equals 50, no? What am I doing? I'm doing the oxygens. 16 times 2, right? Right here is 32. That's this one. And then 16 times 1 is 18, right? So that's that one. And then we add them together, gives you 50. But you already have 2, so you divide this by 2.
So 25?
Yes.
Yeah,
Twos?
25.
Yes, ma'am. That's what's going to go in front of this. See? That's why I
Good
said,
heavens.
yep. Oh, you can get up to more than that. But this is the trick right here with the oxygens. You add them first and then figure out, divide by 2 and then figure out what goes in front, because it makes it much easier and faster. All right.
Okay.
All right. You tell me how you would do this next one. What do you see?
Put a 2 in front of the
2
P.
from the P.
Hold on. Let me
205.
erase. Let me erase all this stuff. Put 2 in front of the P. Which P?
On
P205.
the left.
Ah, see, you started wrong.
Really?
Yeah, you'll see why. Okay, so what did I always tell you? To look at who first?
Oh, I see.
Aha, you do see it, don't you?
Yes, it's
Okay,
a
if you're
odd number.
comparing that, exactly. So what do? Make it even, right? Right.
Put a 2 in front of that P, right? P205 to make it 10.
Right. And now you have 4 phosphorus. Before you would have only had 2. So you would have had to double
Okay.
anyway. You see that? And now
And
you
then
have
5.
5 right there. Correct. See how much easier that became? All one smooth move. All right, let's do this one. This one would be the most complicated, obviously, right? So let's compare. What do you see?
AG needs a 2.
Nope.
Just
Look
put a
at it
2 in front of
closely.
the AG.
Look at it closely. Who do you compare to first?
The oxygen.
Okay, so look, this is what I do. I compare both ways. Who do I need to modify first? Okay, based on this, I need to modify that, because that is a 2 and this is a 1. You see that?
I see. Okay.
Mm-hmm.
So that needs the 2 first in front of it.
Okay. Okay, I see.
And now you see 4. You see that?
Uh-huh.
Then it's
Otherwise,
4.
you would have had to double again, you see? So
Yes.
you always check both ways. Check the AG, that one needed 2, that's fine, but also the O. The O needed 2 also. So that means you needed to put that 2 first. You see?
I see. I see.
Yeah, because you always balance the one that's not alone first.
Okay.
Okay. All right. All right, let's do this last one. I
The
know.
NO3,
Okay, the NO3, what?
we need a
What do I
3
do?
in front of NaNO3.
Okay, hold on, let me get my, put a, oh, that should have had a plus. What happened to the plus? Okay, but you know that's a different one. Okay, so put a 2 in front of this one, or a 3, you mean?
A 3,
Yeah, 3, okay?
which makes oxygen 9 Al. So you need in front of the Al.
Nothing in front of the AL. Look who tripled.
Oh, Na, I mean.
Yeah,
Na
and
did.
right, exactly. And look, you just balanced it.
And it's done. Yeah.
Yep, yep. You just balanced it because the two things that were in balance were the OH and the NO3. The Na and the Al were already balanced. Okay, there you go. Okay, so now we're going to look at the types of reactions real quick. And that's this PowerPoint. And they go together. That's why I try not to, there we go. Come here, you. Types of reactions. So pay attention to the pointers that they're giving you because they're only 5 types. And each one has a pointer that you know how to recognize it based on that. And some of you are more visual than others, so there's also visual aids in here. All right, so like right here. This is the burning of any substance in oxygen to produce heat. Okay, so what's going on here? This is a combustion reaction below. If you look at it, CH4 plus, remember I told you there's always going to be oxygen in the reactants, and the products are going to be CO2 and H2O. You see that? This is methane, actually, methane gas burning, period. Just like when you burn methane. That's all that's going on right there. And this is the chemical equation for it. All right. So that's how you recognize it. The products are always CO2 and H2O. When you are burning a hydrogen and carbon, or also known as a hydrocarbon compound. Now, if you're not burning a hydrocarbon, then you'll have something like this, sodium and oxygen. Burning in oxygen is Na2O. Why? Okay, so you notice what it says. The products will always contain oxygen. And if they're hydrocarbons, they will form CO2 and H2. So, and the main thing also, which is not written here, is you will always find this guy right here in the reactants, because nothing burns without oxygen, right?
True.
And this is all it is. This is a burning reaction. So everything's burning here, okay? All right, let's clear that one. And that one was easy to remember, right? So basically 2 things are becoming 1. You see that? Yeah, there's a plus here, but there's no plus on the other side. This is a synthesis reaction, or also known as combination reaction. Okay, let's go to the next.
So a solid and a gas makes a solid?
Yeah, in this case it does. It you know, it just depends on what it is. This is just a typical reaction, and it changes state, but based on the sodium's a solid, the oxygen's a gas. So usually it's not going to end up being a gas unless it's like water. When we make water, actually it's H2 plus O2. You're actually burning hydrogen and you're making water, right? H2O. And that's a combustion reaction. It's also a synthesis reaction. So both. So they're both, actually, if you look at it. But how do you recognize a synthesis versus a combustion? The oxygen is in the products. I mean, in the reactants, okay? So either one. This one's either one. Okay, so, and there's, you balanced it. And then that one's always gonna have the carbon dioxide and water. You see that? And the hydrocarbons are gonna either be carbon and hydrogen, or you can have carbon, hydrogen, and oxygen because there are alcohols also that burn. And alcohols have the OH group in them. So just for another day, but that's just, I'm giving you that tip too, because it's part of this balancing thing too. All right, so this is what is known as a synthesis reaction, right? You notice how one thing plus another thing become one, right? And this is what I was telling you. See, look at, tell me if this other one didn't qualify. Come on. See, one thing plus another thing became one. You see that?
Yes.
So it does qualify as a synthesis also, but you only differentiate it because of the oxygen. Okay, so let's go back. All right, so this is how you're going to see combination of two or more substances to form a compound. You will have only one product. There's the key right there. See, like in this case, you have hydrogen and chlorine gas becoming hydrogen chloride gas. This is not the acid because it's not in aqueous form. It's in gaseous form. So there you go. It's a combination, also known as a combination reaction, right? Now, how are you going to know what covalent compounds are going to make? You have no clue because covalent compounds make whatever they want. And ionic compounds, though, remember how we learned the charges cancel, blah, 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 blah. So that's how we have to do this. Crisscross the whole thing. That's how the products are going to be. So Al and Cl2, remember Al is a 3+, chlorine's a negative. So this is going to be AlCl3, right? And now you balance. Boom. See? All right.
Okay.
Yeah, decomposition is exactly the opposite of what you just saw. You notice that you have AB becoming A plus B. So basically, you are breaking down a compound into two or more simpler substances, and you will only have one reactant. See, this is the opposite. So one reactant means there'll only be one thing on the left, but you'll have multiple things on the right. All right, an example is the breakup of water. You see that? You have liquid water breaking up into hydrogen and oxygen gas. That's their preferred state, by the way. And it is a decomposition reaction. And the products, remember, you have those binary elements that are Brinkelhoff. Remember, I gave you those? They will always break up in two. So oxygen, hydrogen, chlorine, bromine, nitrogen, there will always be with a 2 subscript. So O2H2, N2, you know, like that. So KBr, see, this is going to break up into its constituent elements. So potassium plus bromine, right? But bromine is one of the Brinkelhoffs. So it always has to become double. Therefore, the balance is off. So you have to balance. You see? All right. Single replacement. We saw these already. All right. One element replaces another in a compound. A metal replaces a metal, and a non-metal replaces a non-metal based on that chart that I gave you. Remember the one that had the colors? Okay. So this is how it works. See, there's the visual for those of you who are more visual. See how the blue replaced the yellow?
Yes.
And it booted it out. That's what is known as a single displacement or single replacement, because that yellow did not bond to anything else. So it cannot be double if all it did was replace one, right? So pay attention to that part. You will always have an ending, like right here. you have copper plus silver nitrate. See these little, this is showing you the actual reaction. Those little long things you see there, that's actual pure silver. That's
Oh,
being,
wow.
yeah, that's being booted out of the compound by this copper wiring. You see that? Yep,
Yeah.
that's exactly what's happening. And the silver is out, and that's what you're seeing. That's pure silver right there. Solid, obviously, because it's solid. All right. And this is what you're going to see. You're going to have a metal replacing another metal, a metal that's, you know, or a non-metal replacing a non-metal. And usually when you see a non-metal replacing a non-metal, it's going to be the halogens. And in the periodic table, they're in the right order. So fluorine is the most active, right? Therefore, if you're replacing chlorine with fluorine, that ain't going to happen, right? Fluorine is the one that's bonded. Chlorine is not going to boot it out. But if it's fluorine that's not bonded and replacing chlorine, then yes, it will. So remember, it always has to be the higher one that replaces the free element, must be higher or more active. Okay, like right here, iron replacing copper, yes. But copper replacing iron, never. Okay, going backwards, you can't. Like right here, see, this is what I was telling you. Bromine is below chlorine. So bromine is not going to replace chlorine at all. You see? All right, and the last one is the double replacement, which we saw a couple. So basically, this is like when you're switching partners, basically, that's all you're doing. So the positive and the positive remain, or the negative and the negative change, whichever one you want to see it, it's either one, because they're both changing, you know, where they could. You notice that here is AB plus CD, and you ended up with AD, which this is the D that came from the CD, and the C got the B, which came from the AB, you see?
Yes.
So they're double replacement, because now not only did you boot one out, but then you replaced it by the other one, you see? So that's why it's called double, because you're actually doing that. You're replacing two. And for those of you who are visual, there's the colors. You see that? All right, and this is an actual reaction. One of the keys to this happening is one of them has to be a solid, like this PbCrO4 right here. So lead, what is this? Lead 2 chromate. This one right here is falling out of solution. You see that? It's no longer in solution, like this one, like this right here. This is in solution, this is falling out of solution. So it has to become a solid, otherwise the ions keep exchanging, bloop, 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 you know, keep playing around. And so this reaction would never happen. So one of them has to commit and say, okay, I'm out. And then the reaction happens. And that's how this works. So that's what it's going to tell you next. And that you check the activity series. So you switch the negative ions, and one product needs to be insoluble, or it needs to be in the solid state. That's what that means, not aqueous. For example, right here, PbNO3 plus Ki. As long as one of them is soluble and the other one is not, then it will happen. So this reaction happened. But this one right here that we're going to see, sodium iodide is soluble, and so is potassium nitrate. So therefore, this reaction does not occur. You see? Right. And now let's go classify. We are going to go back to the beginning. We're just going to classify them if we can. All right, so what's going on here? What do you see happening? I see.
Something with the K.
Okay, look at the K. Yeah, exactly. Look what the K is doing.
It's going.
What did it do?
Did the
Oh,
it got
that's
connected with?
Do you see what it did?
single replacement.
I see what
Correct.
it did, but I don't know
Yes.
what.
It is SR, single replacement. Yay. Why? Because you have a single element, right, being replaced or replacing another one. See? And then you have two single elements, different elements on both sides. And that's how you know. This one took the place of one of these potassiums, right? The potassium, I mean, the hydrogens, and it became KOH, and then it booted out the hydrogen. Yep. All right, let's look at the next one. What do you see happening?
That looks like double replacement.
And you are correct. Because again, this hydrogen went to the right here, right, with the O, and then the sodium, which I'm going to circle, was with the OH. You see that? So if you add H and OH, you get H2O. You see?
Mm-hmm.
And Na plus Cl is NaCl. So yeah, that's a double. Very good. See, I told you it's not that hard to if you really pay attention to the clues, right? So single replacement, double replacement. Let me erase those because we got to go to the next one. Right. Let's see what oops. I can't go to the next one if I don't push it. Okay, there we go. So now we have more. All right. What do you see happening here?
Decomposition.
Very good. Excellent. Yes. One thing is breaking up into multiple. All right. Next one.
Double replacement.
No. But remember, this is the key to this one.
The O2. Okay. Oh, that's combustion.
That's correct. That's combustion. Both of these are. Mhm.
But
And you notice the products are exactly the same, carbon dioxide and water in different amounts, but it's the same product. You see that?
Yeah.
yes.
Okay. What about the next one?
That's synthesis.
Yes, it is synthesis, or it could also be combustion, believe it or not, because look, there's the guy and he is present in the products. You see that?
Yeah.
But we're going to call it synthesis because that's a good one. And what about the next one? What do you see happening?
Double replacement.
Correct. Double replacement. The NaNO3 replace the Cl.
Why it's double receipt?
Because see how this one here is with the silver, but here it is with the sodium. And then here, the chlorine is with the sodium, but here is with the silver. So that means they switched. They switched partners. Yeah, that's why it's double. All right. I think that was all of them. Yeah, that was all of them on that one. Okay, so let's go to the next one. Nah, I don't need to save that one now. Go to the other one. Okay. You guys are good at this. All right, what is the first one?
Combustion? No.
No,
that's true.
No.
That is a single replacement.
Nope.
Dang it.
Synthesis. That's right. Look, one product. You see that?
Yes, I see.
Okay. What about this next one?
I don't know how do you say it.
Decomposition.
Yes,
Composition.
decomposition it is because it is breaking
I
up.
don't want to say
See
it.
that KCl is becoming KCl and O. KClO3, yeah. All right, next one after that,
Synthesis.
single, that's right. Single replacement, how do you know? You have two lonely guys, you see that?
Yeah.
And I call them lonely, but you know, because that means they right?
Smart.
They're single. Yeah, they're uncombined. They don't have a, yeah. All right. All right, let's go to the next one.
I miss your class.
All right, there we go. All right, look at that. What does that look like?
Well, you said it was combustion, but it looks like
No,
double.
number four.
4.
Yeah, it looks like, what did you say?
Composition.
No, see, this is a different one. 4.
Synthesis.
No, not synthesis. Look what's going on.
There.
Might help if I actually color it. A lot of people always like it when I color it, and I'm going to color it for you. So I'm going to just color the NO3 yellow. And I'm going to take this one off, because it doesn't need to be yellow. It needs to be no color. There we go. All right.
Double replacement.
Uh-huh. You see it? You saw it quickly, didn't you? And see, I was going to color the CL green so that way you can actually see the difference. See?
Yeah.
See how it helps when you color it in your head or whatever? But yeah, that's a double replacement, correct. Okay, so DR. And the next one, what do you see happening?
Oh, so that's double replacement again.
Again, that's right. What about number 6?
That's the one you said was combustion.
That is combustion, correct. See how you got the same products again? You see that? Carbon dioxide and water. No, different numbers. That never will be the same because they're different, you know, elements, but in the different numbers of elements. But in this case, you have carbon dioxide and you have water, and you had oxygen on this side. You see that? Yeah. And there's your hydrocarbon. See, carbon and hydrogen. There you go. All right. What about the number 7? Well, the last one you can see here.
Synthesis. Synthesis.
Very good. Yes. Excellent. See, you're all getting it. I love it.
Yeah.
No, I told you this is not the hard part at all. This is the easy part. The harder part is the balancing. All right, so let's look at these. 8.
So 8, decomposition.
Yes. And 9.
Double replacement.
Correct. There you go. Okay, so now we're going to go do a little harder balancing. I know, it's like, dang, we were so easy so far, but not always is it easy, you know, so we got to get the not so easy stuff too, right? So let's go there. Come on. All right, let me go and say escape on this one. No, I guess I just close it. Yeah, no, don't save. I don't need it. All right, so on here, we have what is known as a tutorial, which I would give you a copy of if I saw you in, you know, in class, but I don't. So this is what we're going to do. Balancing equation tutorial. And over here, they give you lots of tips, but we're not doing that. I already gave you all the tips. All of them are right there, except for the one about the combustion. That one's not on there. Like I said, that one's my own. This is something I found on the internet, which I thought was really good, so I used it. All right, so, but what we are going to do is we're going to classify some more. Yeah. And then we're going to balance again. All right, so look at this one. What do you see happening? Let's do the already The already balanced one, that one right there. Okay, so it's the same. So what do you see?
I see combustion.
Correct. That is correct. That is a combustion. Okay, cool. All right, what about this one? Hold on, let me go there. There we go. What about that one?
Double replacement.
Double replacement, correct. What about the next one?
Synthesis.
That one's a little harder to tell, isn't it?
Double replacement.
You're not gonna have something like this, but you notice you started with a single element, right? And he took over the O, right? But remember I told you that when the O leaves, it always takes a hydrogen with it because it's so reactive. They like each other so much that that's what happens here. So it is it's actually a single replacement with a tail. Is what I call it, with a tail, because it always brings something else with it. So it's harder to tell. All right. Okay, how about that one?
Double. No.
No, not double. Synthesis, that's right.
Yeah.
All right. Now look, we are going to balance.
That's hard.
Okay. Remember who we looked at first? The most complicated one. That would be this guy, right?
2.
So you put a 2 in front of that. All right. Excellent. Oops. Sorry. That was supposed to be a 2. Oh, I see why it's not coming up. It's because I put it in this color. So it's not letting me see it. But there's a 2 there. And it's doing it in white. Why? I don't know. Go black. Okay. But that's a 2 there. So for some reason it's not.
Okay, we know it's 2.
There,
That's
not 22, but 2. There we go. There's your 2. All right, so we know it's 2. So look what's next.
3. No.
Where, though? You got to say where.
It's going to be 6, so you have to put the 3 in front of the H.
Yes,
It's 2.
excellent. Oh, see, it's doing this stupid thing. I don't know why it's doing this. It's changing color on me. All right, and then in your connect, you're probably going to have to put a 1.
1.
Yeah.
Will be
So we're just going to do that only because that might you might have to do that in yours, okay? And I think the arrow is missing because of this same thing. Nope, look how many 2s I got in front of here. Every time I put 2, it gave me a 2. That's supposed to be the arrow, but it's not coming up. I don't know why. Oh, anyway, doesn't matter. Okay, so now we classify it too. What is the classification?
Synthesis.
That's right. I'm just going to put a big S right there. Okay, what is the next one? Let's look at it. Okay.
Combustion.
Combustion, right. So check the hydrogen. Divided by 2 is an even number, yes?
Yes.
So then we can we don't have to do a double. We can just balance as is. So put a 3 right here, right?
Yes.
Oh, look at that. That one worked. That one worked. And then here, what do we put?
4.
Yes. And now we add the oxygen. So 3 times 2 is 6 plus 4 is 10. So that means we need a
10.
5.
Oh, what? Oh, you divided. Divided. I forgot to divide.
Don't forget, divided by 2. Yeah, because there's 2 already, right? So it's telling you this is going to be double. So, all right. And this is a?
Combustion.
Correct. Oops. There you go. All right. Next one.
Is a single replacement?
Correct.
No, that's.
Yep. No,
It's
you're right.
also synthesis, right?
No, it is a single. Oh, no, single replacement. You're right.
Okay.
The aluminum is replacing the copper. You see that?
I see.
All right. So how do we balance? Always look at the most complicated, right? Which is this guy. Now compare.
2.
So he's an odd.
Yeah, but you notice there's no evens. So we're okay, right?
Okay.
See, an odd only matters if there's an even, but the other side is CUO.
That needs a 3.
Uh-huh, correct. And now,
2. No, 2.
Yeah.
Yeah, 2.
2. Mm-hmm.
2
There you
from
go.
the 8.
And then what? One more.
2.
No,
2
3.
in front, 3 in front of
3.
copper.
3.
3, because it's copper, right? And then remember, this is
1.
just because we don't want to leave a blank. Oh, and I left a blank. Sorry. I said, this is one of
Why you
those.
put a C over there?
I put a 1 there. Yeah,
Yeah.
there we go. All right. And then, ooh, this one's a very weird one. Okay. So you can kind of tell what it is based on what I told you. There's a single
Double?
element, right? So no, single. If it's
Okay.
single, it cannot be double if it's not replacing anything original. You
I
see, right?
So even if there's one single guy at the bar, it's just a single.
Exactly. With a tail, because when the sodium got booted out, it took an iodine with it. You see that?
I see.
But other than that, it works. Okay, so let's look at it. Okay,
Miss
so
Vibes.
obviously, yes, ma'am. You gotta go.
I have another.
You have another class?
Yeah, me too.
Okay, then go.
Yes. When did you say that our final exam? Are we gonna be in person?
No, we're not in person for final.
Okay.
It's on Connect.
Thank you.
Oh, take it in Connect.
Mm-hmm. Yes, ma'am. And we'll continue this next time.
On
Okay.
Wednesday? Okay.
Yeah.
I have a question.
Yes, I will. I'll put you in. All right.
Okay. Thank you.
You're welcome. Bye-bye.
Thank you.
Mhm.
Thank you.
Bye.
Question.